Great. So this is the last session of the day, and we'll do our best that this is the nicest one for you today, but it was a really, really tough competition. Some very interesting sessions today. So Eddie and Babesh, you already met early because we did the bonus session. And I will find this. This will definitely help. And we talked about this. Babesh is a senior security researcher in our group in Nepal, and he joined us after finishing his studies, his BE degree in electronics and communication. And that's close to my heart because I'm actually an electrical engineer as well, a long time ago. And like everybody else in our security research team is spending probably half his time reading and only the other half of his time actually writing and trying things out. Lots to learn out there. And hopefully we also share some of it. So or rather Babesh, is going to talk about hunting for malicious browser plugins that can collect credentials. And since we have been talking about Ukraine the entire sessions this morning and yesterday morning, also detecting a specific infected ISO Ukraine attack that is very recent from December this year.
So MITRE has already added the browser extension technique back in their version 1 released on January 2018. So anyone can develop browser extension that can steal passwords, cookies, they can create keyloggers, that can basically do anything. So not much complicated there. So, and it has been recently used by APTs. So the most recent one was by SHARPTEXT, which is a North Korean APT group. So other vendors might name it. I think you have heard Kimoski group. So this is one of the others is aliases of it. So commonly used in post-exploitation phase. So after the endpoint has been breached, so they use it for persistence and as well as collecting data, normally emails and other credentials. So the latest one, the malware that the browser extension used is SHARPTEXT. So the latest version is version 3, which supports the major Chromium browser engines. So Chrome, Edge, and Whale. Whale is the one commonly used in South Korea. So both three are based on Chromium engine. So, and the latest one supports stealing emails directly from Gmail and AOL mail accounts. So nothing fancy there, just it relies on the Chrome's DevTool permission. So if a browser extension has DevTool permission, it's a very powerful permission. So it can directly inspect web traffic, it can monitor all tabs, it can do anything, it can create any panels, so basically it's master control. So it's just like opening inspect tab and inspecting everything that the user has opened in their browser. So, and basically Chrome has a safety feature where it will not allow directly manipulating the configuration file, because for this the APT group have directly modified the configuration to install the extension. So Chrome has a safety feature, so it has basically stores the configuration in 2 files named preferences and secret preferences. So the current config will be loaded in the preferences, and a good known copy is stored in the secret preferences. So on a normal boot up, the Chrome will check if there is any drift between those 2 versions. So if it finds any drift, it will just throw out the preferences file and it will load the secure one from the secret preferences. So it will not allow anyone directly to modify the configuration file, but there are some methods found by other security researchers where there is a trick to make sure that you can now, if you have the preferences file as well as the secret preferences file as well as some other values which the attackers will require you to exfiltrate, then you can now manually edit the configuration file at their end and throw them back to the infected endpoint, so that now when the user opens the browser at the next run up, the both validation will be passed by the Chrome, and the malicious browser extension will now be loaded in Chrome. So As mentioned earlier, it will use the DevTool API to view all the responses as well as the network traffic of the user, and will try to steal emails as well as attachments. So now the question will be, how will your SOC see this? How will your SOC detect and hunt on this? So for this, it will require some active agent that will pull the extension data, so that the extensions, all the extensions are stored in the Chrome's installation folder. So basically there are manifest file as well as the other files. So now you require some form of mechanism that will pull the extension data and make it readily available in your SIEM. And our new upcoming EDR, Agent X, we have integrated OSQuery in it. So now, if you have not heard of OSQuery, so it is a very lightweight OS instrumentation agent. Basically, it will run as an agent in your OS, and you can schedule queries that it will regularly pull, and it will put it in its database, so that you can now get most of the information from your OS, and you can send that to your SIEM, so that now it will basically plug in the work. It will do the work of an active agent, so that now you can now pull the browser extension data using OSQuery, and it is bundled with Agent X. We provide the baseline configuration so that it will be easier for you to go and up and running using both Agent X and OSQuery. So we provide the baseline config, so that in the configuration you can use schemas, and the OSQuery uses the SQL schema. So in this two example, we will pull the Chrome extensions table and will join it with the user, so that we will identify which user has installed which extension. So we will pull this every 1 hour, as well as we will pull the snapshot every 4 hours, so that we will know at which point of time the full set of extensions installed by the user, so that you don't have to go back far to identify the full list. So these are all out of the box we provide. So this is an example of an OSQuery log, so that you can see in the event source OSQuery. So event type is the schema name. Here we see the Chrome extensions. We have Firefox, Edge, so no problem there. So here we are hunting for extensions which are installed from outside the web store. So that normally users will go to the Chrome web store, install the extension, so that normally those activities will be seamless. In this case, like the threat actor has used, they have manually exploited, they manually created an extension, malicious extension, imported that to the compromised endpoint, and installed that manually, so that you can see that the the columns from installation from web store, it is false, so that it will readily stand out from the noise. And you can see extensions installed in a non-legitimate location, like all extensions will be stored in the default location, or if you have Edge or Chrome, it is in the extension folder, and other threat actors will install extensions normally on the program data or public or other suspicious locations, so that it is easier and it is very much useful to hunt extensions installed from those locations. So OSQuery will also pull the permissions information, so that now you can directly search for high suspicious as well as powerful permissions used by extensions, because the DevTools permission in this case is not normally used by majority of extensions. So that here you can see a user TA admin that has installed SHARPTEXT extension that uses DevTools in one of its permissions. So now the OSQuery will give you an exact timestamp of when the Chrome extension was installed. So just go and search for any suspicious activity around the time frame, because now you can go and hunt for anything like PowerShell, command shell, run your playbook here, so that you will identify how the Chrome extension was installed in the system. In this case, it was installed using PowerShell script, so you can see command shell opening and downloading the PowerShell script using call.
Around the time frame.
So, and if you have Sysmon or if you use registry auditing in Windows, you can see the Chrome extension and the PowerShell scripts being dropped in program data. So normally you will look for wall writable directories that malware normally drops because it requires no permission there. So normally program data, perflux, profile, and as well as the both local as well as roaming temp directories. So, and for this also we provide a very good new source template so that it will make the hunting easier for you. So we have both 3 dashboards in the source template. One is for overview. It will go if your organization uses both Chrome as well as Firefox browsers. So in the overview you will get the aggregate view, and in the separate dashboard tab you have one for Chromium and one for Firefox. So and using this source template you will get some idea of how to hunt. And always remember there is some feature parity between Chromium and Firefox. Basically all the permissions as well as the installation timestamp and other information are not present in Firefox extension. So there is big visibility gap. So it is recommended not to use Firefox in enterprises. So yeah.
Right. So you saw the multiple steps we went through in the research and in building the actual logic of detecting this. And then you get the end result. Basically, this search template as a template would give you the full answers without having to go into the details.
So not only this, now you have OSQuery. So now you can run any OSQuery, basically any OSQuery using the SOAR. So we have channeled that through the AgentX agent. So if you have AgentX as well as OSQuery running in the system, you can run ad hoc queries. So now in this here, you can see we have run an investigation OSQuery playbook here. So let's say incident has triggered, you have a host, you have a user. So now using that entity, you can now run OSQuery playbooks to identify whether the AV or firewall was enabled at that time or not, or whether what was the version of the OS. So the version is also important because some security features is not present on every version, just like App Logger is not present on other non-enterprise versions. So you will get host uptime that will give you some idea of when the host was last down for patching, as well as where if the credential might be still alive in the session. Like if you have a host that is alive for 7 days, 30 months, you will see that the host will contain many memory credentials in the memory that will be ripe for collection, either using Mimikatz or Lajegness or others. So leverage SOAR that will basically use OSQuery not only for detection, you can use for investigation and as well as enriching any information for your incident.
Right. So before we continue to the second story of the advanced session, any questions about how you detect and what you do with the detection of malicious browser extensions? Questions, anybody?
So you mentioned a specific use case where Firefox shouldn't be used in enterprise. Can you repeat, please?
So if you go and get the data for both Firefox and Chrome, so you will not get the permissions as well as when the browser was installed, what the permission the extension has. So that information is not present on the Firefox.
Okay.
So you'll just you'll just get a blank there.
Firefox doesn't store.
Yes.
So it will make it much harder for you to detect that an extension, much less a malicious extension, was installed.
So if you want to try the playbooks, you can do that in the tech.
In the tech bar, we have everything we showed here available and running. And if you want to see it step by step, play with it, you can do that. Okay. Last for the day, detecting an infected ISO. And the story around that, this is a quite recent attack. So we talked about threat intelligence. Quite a number we're supporting.
Okay. So first step is choosing a suitable TI report so that you will get maximum ROI from your hunting, so that you will not waste your time doing unnecessary hunt or doing hunts that is not give you much value out of it. So what are the criteria? The main criteria you can use is one of the best is industry vertical. So if you are on financial, if you are on commerce, if you are on insurance, so it will, you just look for threats that are operating, that are targeting your industry vertical, so that the same threat might be, there is a high chance that those same threat will be attacking you as well. So another one is geolocation, just like Ukraine. The Russian threat actors are very active on Ukraine. So if your business resides, or if one of your offices resides on Ukraine, better expect to have solid defenses on Russian threat actors. So another one is technology stack. So if you have full Windows shop, so no point doing hunting for any Linux or other stack based. So another one is industry trend. So if you go, just look for prior incident or prior TTPs used by threat actors on your industry, so that you can get an idea of what to expect in the future, because normally the patterns will be repeated over time. So this one is chosen, we have chosen this one from the Mandiant report based on UNC 4166. UNC is Mandiant's categorization for threat actors that are not, do not have clearly isolated or have information clearly on what their supposedly linked attribution as well as their supposedly motivation are. So this one is equivalent to the DEB tag of MSTIC. So this one is not, they have somewhat of a confidence, they have assigned low to medium confidence to be them, the threat actor to be control, or they are GRU operatives. So GRU is the intelligence division of the Russian army. So Russia has basically 3 different intelligence divisions. One is for SVR, is for foreign intelligence. The local one is FSB, and for military is GRU. So if you have heard of Fancy Bear, that is APT28, that was in the news for hacking the DNC in the 2016 election. So the GRU is also, Fancy Bear is also from the GRU. So they and UNC are both from the GRU. So what the threat actors did, that they trojanized the Windows 10 installers and distributed them in the Ukrainian and Russian language store site, so that this one is the first occurrence that the Mandiant has seen where threat actors have used trojanized ISOs for espionage campaigns. So what they did was, there are basically many legitimate scheduled tasks present in a basic stock Windows installation. So what they did was, they just modified one of the legitimate ones, so that now they don't need to create a scheduled task. They just used an in-house one and just modified and added a command to use PowerShell that will use call to download the script and as well as the command from the Tor from Tor. So you can see on the starter program, you can see the program chain there on the scheduled task. So gather network info is a scheduled task that is present in Windows. They just modified it. So if you try to hunt for this, you can use process creation. So no sysmon required here. So if you have just the inbuilt default Windows one, just use label process create. No need to use event IDs, because if you use labels, so if you don't have sysmon, or if you have sysmon, it will not matter, because we have used both the process create label on both the data sources, so it will be easier for you to use the queries. So just use for PowerShell spawning call. So you will see here, for this you will require 2 things. One is enabling process creation, and another one is enabling command line auditing. If you have not enabled command line auditing, you will not see the command here, data here. So there are also nuances here, like if you go and follow the Microsoft or CIS benchmark, they will recommend that you do not enable the command line auditing, because it will expose sensitive data, like if you have administrator running scripts, so the passwords, username will be exposed in the field. So you have to tread here carefully. So as mentioned here, they don't have directly use Tor, they use the Tor to web gateway so that you can directly access Tor's onion sites from the ClearNet. So it will have Tor.ws extensions here. So directly use whatever network logs you have, IDS, firewall, proxy, just use look for the onion.ws domain or URL field, and you might get a hit here. So for the reconnaissance, they do use WMIC. The WMIC is the default command line for the WMI provider in Windows. So it's a login basically. So you can use WMIC present on every Windows to directly pull any in OS data. You can think of it like an inbuilt OS query. So you can use WMIC to check what applications are installed, what processes are running, what users are currently logged in the system. So WMIC is a very powerful tool that uses WMI in the background. So you can see, you just go and search for WMIC activity. You can go search for command line patterns. So Microsoft also now recommends to disable as well as recommend blocking WMIC using their either WDAC or app locker. So on the latest Windows 11 build, they have removed the WMIC and made it as an optional feature because basically they do not now use WMIC. So you can see just attackers use it. So another one is now the attackers have used the setup complete.cmd for to put additional tags. So basically it is a legitimate file. So admins can modify and put scripts on this basically script. It will do that. Windows will do that after Windows has completed installation. The Windows will run whatever commands that was put here in this script, so that now attacker basically do further thing like they had disabled the telemetry to Microsoft. They have disabled other network telemetry systems, so that if you want to check the ISC hash for this, or if you want to check whether this file is present or not. Basically, in most of the cases, this file will not be present. So in this case, threat actors have specifically added this file in the ISO, so that you can use either the AgentX playbook, where both AgentX as well as OSQuery playbook, to check the hash of any file on the file system. So in this step, we have just checked the MD5 hash of this file path, so that we can now check this ISC with the threat report. So if the result comes here, you can now be sure that this file does exist in that path. So just a workaround. So another one of the most used feature in PowerShell due to its versatility is inbuilt archiving commandlet. So no need to use RAR, no need to use 7-zip. Just use the inbuilt compressed export CSV. Sorry, sir. I just skipped a step here. So basically, you can use the PowerShell export CSV command, so that now you can pull the data using PowerShell and make the data ready for exploitation. So just export the data, use the export CSV command, and make the data so exploit the CSV file later on. So just use here we have used the PowerShell script block logging. So short introduction here. PowerShell, when PowerShell was introduced, basically on version 1 and 2, there was no auditing here. So you could not know what was run in the PowerShell. So basically you can run anything. You can run Windows API, we can run syscall, you can run .NET. So there was no visibility, and there was report that malware threat actors was the usage rate of PowerShell by threat actors rose by 600% to 100% because there was big visibility gap here. So Microsoft plugged that gap in version 5. So in Windows 10, you will get version 5.1. So they had added module logging, script block logging. So they are not enabled by default, but if you enable them, and we recommend you to do that because we have many analytic rules that uses this data source. So basically, the attacker, you can log, PowerShell will log and every activity the attacker does. If he does the command shell as well as script, it will log whole scripts, it will log whole pipeline, so you can directly look for any signature matching. If you want a signature, if you want look for source for certain commandlets, if you want to look for power view, power exploit, or if you want to look for Empire C2 payloads, basically it will give every information. So we recommend you to enable this. And basically back to the Tor, you can use correlate and maintain a list, up-to-date list of Tor IPs, because that is readily available in the internet, and regularly maintain that IP list and just search if any of your endpoints are communicating to Tor IPs.
So regularly update. What you see here is a list. I know that most of you probably know how to use lists. You can update those lists using playbooks. So you can periodically reach out to an external provider and have not just a manually updated, but automatically updated set of lists for pretty much anything that you need. The list that we're generating from IOC is a list that you can use in your searches, and Tor IPs is also a great example of something that makes a lot of sense to actually update periodically without you having to worry about it, so you have it as a logical construct in your searches.
Question, please.
Sure.
That list, does that contain more than 1,000 entries?
I think close to 10,000.
Okay, yeah, because we have a limit on all requests with 1,000 when we use the list. So that's not
1,024 technically, and that's the
Oh.
default we've been told. It can be changed, but that's
With
the
more
default.
memory.
Okay.
We can look it up.
So this one is for looking for SSS tunnel creation. So the threat actors have used the inbuilt SSS tool to build a tunnel, so that now they have channeled the proxy, the connection from the compromised endpoint back to the C2 server. So you can see the uses of OpenSSS and using the -R remote port forwarding feature to create tunnels. So basically, the process creation here is process creation logs are very useful. So no need to, if you don't have, you do not inspect network logs, if you do not have any SSL inspection capabilities, so you can use fallback to this process creation here to identify creation of tunnels. So back to the PowerShell, like I said earlier, event ID 4104, that is script block logging. So you will get everything. So you can search for every command. So like you will search for uses the PowerShell download cradle using .NET or either commandlet to download file. So just you can directly basically search for source code as IOC is using this look. Yes.
I remember that we had some trouble with the events getting so big that the limit of 12,000 bytes.
I think we can increase that collection limit. Basically, if you talk to the support, they will guide you through to increasing the syslog character count.
Have you seen that the events can get very big?
Yes. You can basically get 60,000-70,000 characters. Basically, base 64 payloads. If the attackers have used base 64 to converted the dead tools to base 64, so it will log the whole tool as base 64. So you will the log volume as well as the log size is very big.
No, and if you're worried about the opposite of basically generating too much traffic and too much logs, you can go the other way around. Search for a very large command and only then go and fetch statistically 1 or 2 or 5 of those and inspect them rather than collect every single one.
So now we are going to reach the last step here. The attacker is using the inbuilt PowerShell compressed archive to pack up all the files into a zip file, so that now it will be very easy to exfiltrate the data. So here we are again using the PowerShell script block, searching for, basically there is one very high fidelity alert, basically search for searching for, recursively searching for files in a directory, and followed by, in the same script block, for the uses of compressing command. Basically what attacker do in this line of command, basically they iterate through a directory, they look for files of interest, and they will zip all the file and compress all of them for exfiltration. So this is one is a very high fidelity alert. So basically look out for this. And at last they have deployed services as backdoors. So they already have other access through the task scheduler, as mentioned earlier. So they have added, they have created a new service to act as redundant backdoor. So just you don't require additional log sources, just the default service installation log from SCM. This relies on the system log. So you normally ingest that log, so no problem here. Just look for this creation of this service. And in the schedule tasks, you can see, just look for any suspicious activities run by a task schedule task. So what to look for in what commands or what arguments that might be suspicious, if you want, basically look for any CLI activities and any DLL or any files used that is not present on default directories. So just search for uses of directories of either wall writable directories like perf logs, temp directories, or public directories, or look for execution of run DLL or other lol bins, basically. So this will remove basically most of the noise you can see, because normally this type of schedule tasks normally do not run in Windows. So if you have a good baselining here, so the noise, the malicious activity will bubble out from the noise. So at the end, we have released this new playbook. Basically, you can use this playbook to investigate any service. So let's say you have a new Windows service creation incident. So basically, now you can use this playbook. It will go and check the hash of the service binary in threat TI sources. Like you can go and check the reputation score in VirusTotal. Say, let's see if that might be suspicious. You can check the prevalence data. So you can ask the SIEM if it has seen this same service installed in other Windows hosts, so that if the same service is being installed in many of the systems, so basically that might be a false positive here. So we have made this all easier for you, so that all the playbook will all write the outputs back to the incident as comment, so that no need to do any manual investigation in this.
Now, this is leveraging Babesh's work is always a great way of getting ahead. But even if you do the same things in your SOC, once you do it once, right, you had your best guy, the one who, or one of the few who writes code, actually go through it and do the full session and verify that it works. But now you want everybody to use it. Encompassing it inside a playbook when it's a multi-step process that is quite complicated is much easier than actually teaching everybody how to do it, although you can, of course, still do it manually.
So
okay, so the summary. First of all, this is a supply chain attack, right? Not the standard supply chain you would expect, but if SolarWinds was hard to detect because it's somebody you trust, although this is somebody you really shouldn't trust, right? You're not downloading your software versions from torrent sites, but some of your end users definitely are. And with so many of them at home nowadays and working remotely, this is not something we can ignore. So yes, it's not the standard supply chain attack, but it's a pretty ugly one because the ISO in itself even when scanned by a pretty good tool, wouldn't actually show anything wrong with it. And for the end user, there's actually nothing wrong with it, and they can use whatever is in that ISO. The only thing is that, hey, once you realize what it's doing, using other sources, you can at least go back and hunt for the things that were added to the ISO configuration, right? There's no malware tools, there's no backdoors that are there right out of the box, but the configuration would actually get there. So baselining of many things. We saw it before with the browser. We saw it now with communication. It's great to filter out the noise. It somehow looks the wrong endnotes, but I was talking about the right ones. So actually being able to search for those things when it's complex, you can rely on us to provide the additional capabilities, and you can rely on SOAR to actually do exactly what playbooks are supposed to do. Playbooks are a list of things that you do when something happens, and you want to really put it into writing and into execution as quickly as possible and as often as possible, because you don't want to go through the hard part twice. The first time you have no choice, unless you're lucky and somebody else was attacked with the same attack before you, and you can rely on IOCs and on content we already created, right? But if not, at least not fall twice for the same problem. And attackers do tend to go after places where they've been successful. Just because you've been attacked once, it doesn't mean that the statistic is you get attacked every 2 years or every year, a big successful attack. So if I've been attacked last month, then I'm safe now. Hardly. So it's great to get to be efficient. If you want to see the thing live, we have it in our bar. And if not, perfectly fine. We're the last session for today. I hope you enjoyed, and thank you very much for coming. And thank you very much, Babesh and Basudev.
Eddie, I would like to add one thing. So we are releasing the Windows configuration guide in matter of days, if not weeks. So that will contain the entire configuration required in the Windows side. What needs to be configured, what is enabled by default, what it is not, what you need to do extra, and how are our alerts associated with the typical configuration steps that you need to follow, and the coverage you will get from the MITRE ATT&CK framework by enabling those configurations. So that will be really handy for the analyst.
Yeah. And quite soon after that, we will have it templated into AgentX. So it's not just reading material, it's execution material. Great. So thank you.